So what is a neural network? Well, it's often described as mimicking the brain. It's a neuron or node that represents an algorithm. So data is inputted into a neuron, and based on the output, the data will be passed to one of many connected neurals. The connections between neurons is weighted. I really should have highlighted that one. That's very important. The network is organized into layers. There will be an input layer, one to many hidden layers, and an output layer. So here's an example of a very simple neural network. Notice the NN. A lot of times you'll see this in ML as an abbreviation for neural networks, and sometimes neural networks are just called neural nets, so just understand that's the same term here. What is deep learning? This is a neural network that has 3 or more hidden layers. It's considered deep learning because at this point it's not human readable to understand what's going on within those layers. What is forward feed? So neural networks where they have connections between nodes that do not form a cycle, they always move forward. So that just describes a forward pass through the network. You'll see FNN, which stands for forward feed neural network, just describe that type of network. Then there's back propagation, which are in forward feed networks. This is where we move backwards through the neural net, adjusting the weights to improve the outcome on next iteration. This is how a neural net learns. The way the back propagation knows to do this is that there's a loss function, so a function that compared the ground truth to the prediction to determine the error rate, how bad the network performs. So when it gets to the end, it's going to perform that calculation, and then it's going to do its back propagation and adjust the weights. Then you have activation functions. I'm just going to clear this up here. So activation functions, they're an algorithm applied to a hidden layer node that affects connected output. So for this entire hidden layer, they'll all have the same one here, and it just kind of affects how it learns and like how the weighting works. So it's part of back propagation and just the learning process. There's a concept of dense. So when the next layer increases the amount of nodes, and you have sparse. So when the next layer decreases the amount of nodes, anytime you see something going from a dense layer to a sparse layer, that's usually called dimensionality reduction, because you're reducing the amount of dimensions, because the amount of nodes in your network determines the dimensions you have. Okay.